Okay, today is Friday, January 7th. If we take a look at the calendar, as structure and function of exocrine and endocrine glands and nervous system and endocrine system link. I've been getting a little ahead of myself when it comes to this calendar. In fact, to give you an idea of what I was going to teach today, I was going to teach next Wednesday's lesson. But I figured, well, let's stick to the calendar because a lot of people are stuck at home because they're quarantining or whatever, and they have to go by this. So what you guys do is you look at the calendar, you find out what we're doing that day. You then go to YouTube and you watch the lesson for that day. So I'm going to go ahead and switch over to my notes, and I'm going to title our lesson.
Please pardon the interruption. Please send any students ready to make up their exams to the media center. Thank you.
All right, sorry for that interruption. Here we go. Today, we're going to distinguish endocrine and exocrine more specifically than into the blood and out of the blood. And then we'll get to how the nervous system and endocrine system are actually related and they work together and how they kind of work autonomously from each other. All right, so here we go. Differences between endocrine and exocrine and nervous system plus endocrine system equals control and communication. That's what the two systems are meant to do. So this is not going to be a very long lesson. It's not going to take all period. I don't anticipate it to take all period. So the first thing I'd like to do with you all is distinguish or compare and contrast endocrine and exocrine. Now you learned this either on Tuesday or Wednesday of this week. Eva, what does the actual word endocrine mean? Flip those. Secreting in. So secreting within. That's what the word actually means. Secreting within. Good job. Dan, what does exocrine mean? Secreting, not secreting out. All right. Well, you guys have endocrine glands and you have exocrine glands. What we need to put a stamp on and move on from is why are exocrine glands, by definition, definitively not considered part of your endocrine system. So endocrine glands lack ducts. And I don't mean ducts like quack, quack, D-U-C-K-S. I mean ducts like D-U-C-T-S. Right above, near over by Dylan's head, there's a giant air vent in there. If Dylan were to crawl up in that air vent, he could be in the actual ductwork of South Hall. And he could crawl into any classroom he wanted to. Kind of creepy. You ever see the movie, anybody ever seen the movie The Breakfast Club? Remember that part where the bully, like the bad kid, the criminal, if you will, he climbs to the ductwork from the library to that closet he was being put in? Well, that's because we call it a duct because it connects one chamber, this room, to another chamber, like a closet or another classroom. In your endocrine system, it doesn't have ducts. It doesn't connect from one organ or gland to another. However, exocrine glands possess ducts. An example of which I could give you is your liver. Your liver is your largest internal organ. If you look at me, it's right here. This is your liver, right under there. Your stomach's over here. Your stomach's not down here. Your stomach's up here. Your intestines are here. You'll learn that in the fourth quarter. But the liver produces a lot of juices. Food does not enter your liver. Your liver produces digested juices. Your stomach carries food. Your intestines carry food. So how in the world do those digested juices, like bile, for instance, get into your stomach and your intestines? They get in there through ducts. These juices are secreted into the stomach, intestines, and gallbladder via ducts. You even have there is a enzyme that digests fat. Whenever you have cake or butter or loaded nachos at the restaurant and there's cheese all over it and there's a lot of fat and cheese, you have a digestive enzyme that your liver produces called bile, B-I-L-E. So I'm going to use that as an example. Bile. Bile is made by your liver and it is stored in your gallbladder. Some people have to have their gallbladders removed for one reason or another. Gallstones maybe, or their bile is, or their gallbladder might be cancerous, who knows? And the doctors will just connect the liver straight to the intestine. Whenever you eat fatty food, we all eat fatty food. Red meat is fatty food. It needs bile to digest. And bile will be secreted by your liver, stored in your gallbladder, and then released into your small intestine. That is because of the ductwork. Bile is secreted by the liver, stored in the gallbladder, and released into the intestine. And this is all done because of ducts, D-U-C-T-S, duct work. Funny story. It's not so funny. It's actually very disgusting. Have any of you ever babysat a baby? Have you ever had to change a baby's diaper? Has anyone ever changed a baby's diaper? Okay. It's kind of gross. This is human anatomy. It's kind of gross, but it's legit. It's an honest question. What color is baby poop? Green, yellowish. Ugh. Do you know why? Grace? Where did you hear that? It's not the sugar. It's the fat. Breast milk has fat in it, as all milk does, okay? What nutrient, I should say, what macromolecule do babies, especially in their first year of life, need a lot of? I'll give you a choice. Carbohydrates, lipids, proteins, nucleic acids. Which one do they need? They need lipids. Lipids helps a baby's brain grow. In fact, there's a disease called Tay-Sachs where the brain grows faster than the skull, and eventually the skull strangles the brain. The baby dies, unfortunately, because the brain is squeezed. Well, anyway, babies have a diet high in fat. They're supposed to have a diet high in fat to build up their brains. As a consequence to that, they have a lot of fat in their digestive system that they break down. What enzyme breaks down a lot of fat, guys? I have it written on the screen. Bile does. Guess what color bile is? It's like a greenish yellowish color. And so the more fat that you eat, the more bile that you need. And the bile kind of stains the food that you're eating. And so when you actually go to the bathroom, it can make your stool, which is your poop, a greenish yellowish color. So my first year ever teaching anatomy, I had a boy, his name was Carlos, like a junior, say, "Why is poop green?" I told him that whole story I just told you. He goes, "So if I go eat a lot of junk food and stuff, I could do that?" Well, possibly. So he goes home and serves that as his own personal homework assignment. Eat a lot of fatty food. He comes back the next morning like the kid on Christmas. He's like, "Guess what, Mr. Thorson? Guess what?" Oh, God, here we go. "What, Carlos?" "It was green. It was so green. It was disgusting. I just did a third period. I took pictures. You want to see?" I didn't, but he was showing it to other people. Great pickup line. "Hi, my name's Carlos. You want to see my turd?" Anyway, that was pretty nasty, but I mean, that's pretty much why. Pretty gross. But anyway, you guys have various glands that are considered exocrine glands because they don't secrete in your blood. They secrete in areas that are not your blood. So as a final stamp on this exocrine thing, I'd like you guys to try to help me identify several exocrine glands, more than just the two that we did with your integumentary system. We obviously have your sweat glands. Those are exocrine. And what are the other ones in your integumentary system? Well, sudoriferous are sweat glands. They're same thing. Sebaceous, very good. Sebaceous glands secrete oil. Sebaceous glands are what kind of cause you to get zits and acne. The oil that comes from sebaceous glands lubricates hair, and sometimes they get clogged and causes acne. What are glands in your mouth? Salivary glands. You go to the dentist and you make a lot of saliva, the dentist will say, suction, suck all that spit out. Salivary glands. Okay. Your liver can categorically be considered an exocrine gland. It is a digestive organ, no doubt about it. But because it doesn't receive food, but it has a digestive function, it produces digestive juices, it could be considered an exocrine gland. And then the big one, one of the most important structures in your entire body, your pancreas. Your pancreas is shared by your digestive system and your endocrine system. It produces digestive juices like insulin and glucagon, but it also produces digestive juices like pancreatic amylase. So these are basically the glands that are not endocrine glands, except for this one. I'm going to put this in parentheses. It is shared between digestive and endocrine. Just like your testes and ovaries, what two systems share those? Endocrine and reproductive. That's right. All right, let's move on over back to endocrine, okay? These lack ducts. What they basically do is they have a lot of blood vessels that transverse throughout them. Blood vessels and lymphatic vessels transverse. Transverse basically means like crisscross. They go throughout endocrine glands. And the glands secrete hormones into the vessels. You guys have blood vessels, we all know that, but you also have lymphatic vessels. Okay. Can you guys perhaps tell me all the endocrine glands? Start with the head and just work your way down. No cheating on a textbook. What can you remember? Because you will eventually have to know all these by heart. Tell me one. Pituitary, the master gland. It tells all the other glands what to do. Not yet. Pineal. The thalamus is not a gland. It's a part of your brain that controls where signals go. Okay, move down to your throat. Thyroid, that's a big one. Controls your metabolism. What's kind of speckled inside your thyroid? Parathyroid. Helps control calcium regulation in your body. Okay, keep it going. Move on down. Move down to your abdomen. Adrenals. Now, here's something I haven't taught you yet. You have two adrenals. You all should know that. But within one adrenal gland, it actually has two parts. And I haven't taught you this yet, but you'll eventually get it. There's the adrenal cortex, which is the outside, and the adrenal medulla, which is the inside. It's kind of like a Reese's peanut butter cup. A Reese's cup has two parts, the chocolate part and the peanut butter part. The cortex is like the chocolate. The medulla is like the peanut butter. It's inside. And they have two different functions. And then you have the gonads. Apparently, my students are really starting to pick up on these terms because I heard one of my students yell at his friends in the hallway, "Hey, come back here, gonad." I mean, good job, I guess. At least he knows what the word is. What is the male gonad? Testes. And the female gonad? Ovaries. Be sure you know the male and female symbols, everyone. All right. So that about does it for the differences between endocrine and exocrine. I think we'll finally put that one to bed. You'll see some of that on your mastering this weekend. I want to remind you, don't wait until Sunday night at 10 o'clock to try to do it. You'll go online. You're going to text me. The website won't load. What do I do? And I'm going to tell you there's only 2 hours left in the day. Why did you wait? Don't wait. You don't have a large mastering this week, so get it done. Let's go ahead and switch gears now to the second part of today. We're going to talk about endocrine versus nervous system. Both systems are means of communication within the body. Eeny, meeny, miny, Noah. Noah, what is the bridge between the endocrine system and the nervous system? What connects the two? What structure in the brain? The two girls to your right are dying to tell you. In fact, Eva looks like she's about to whisper to you. Don't do it. I know you guys too well. Noah, come on, begin. I'll help you out. It's Friday. Feeling friendly. Lightning won last night. You're wearing a Buck shirt. We're on the same side. It begins with an H. HYPO. Yes, the hypothalamus. The hypothalamus is a bridge to the nervous system from the endocrine system. This gland or this structure is called a neuroendocrine organ. And I don't recall if I taught this to this specific class. I guess you guys will tell me here in a second. Did I tell you the two hormones that this makes? What are they? One is called the love hormone, oxytocin. Oxytocin is made in your hypothalamus, but it is stored in your posterior pituitary. What is the other one? ADH. What does ADH stand for? Antidiuretic. Does that make you pee or hold your pee? Hold your pee. Antidiuretic. If I was your doctor and I gave you a medication, I said you better stay close to the bathroom. This medication is going to make you pee a lot. The medication would be considered a diuretic. Antidiuretic means you're going to hold your pee. You're going to hold your fluids and your electrolytes. Antidiuretic hormone. Very good. It is also stored in your posterior pituitary. So I just want to make sure you guys get that. Now, to finish off today, we're going to have some features. We're going to have 3 column notes here. First column is going to be features. Then we're going to have the nervous system. And then we're going to have the endocrine system. First is going to be, the first feature we're going to discuss is the means of communication. The communication method. How in the world does the nervous system communicate with other cells in your body? The other day, I was walking my dog and I was barefoot letting him out to pee before bedtime. And it was really dark and I stepped on a rock. And before I even put my full weight on the rock, I could feel it and I jumped off of it. How did my brain know that my foot was about to step on a painful rock? How does the nervous system communicate? It sensed it. Well, what traveled? Okay, nerves and neurons And what do we call those signals that communicate from one neuron to the next neuron, or even from neuron to muscle? An action potential is the electricity that travels down a neuron, but eventually the electricity gets to the end of a neuron and causes the release of what from a neuron into the cleft? Yes, neurotransmitters. Good job, ladies. So guys, here is a neuron. It's going that way. What type of signal travels down the neuron here? Is it electrical or is it chemical? It's electrical. So this part is electrical. And then those little dots I drew are the neurotransmitters that are being released. Are those electrical or chemical? Those are chemical. So we have the neuron and we have the neurotransmitter. Dopamine, serotonin, melatonin, acetylcholine. We went over a lot of them last semester. Okay, and then we have the endocrine system over here. These are glandular cells. Glandular cells just means that they're cells of a gland. Like pancreatic cells make up a pancreas, adrenal cells make up an adrenal gland. And what chemical substance is released from glandular cells? What do we call those? Hormones. Very good. How do hormones travel throughout your body? Blood vessels, right. And what do you call the cells that a hormone specifically reacts with? It's the name of a shopping store all over the country. Target. They're target cells. Correct. What makes a target cell a target cell? We'll get to that on the next line. But I want to compare the nervous and the endocrine to something you guys are definitely familiar with. If I know that nobody your age has Twitter, but let's say that you are a disgruntled former Tampa Bay Buccaneers football player who was just cut this week, and he has a social media profile, and he has a lot of them, and he posts a bunch of things on Twitter. Would you consider a tweet to be an endocrine hormone or a nervous system neurotransmitter? In other words, would you expect social media where everyone can see it and everyone can hear it? Would you expect that to be a nervous system or endocrine system? Nervous. Social media is like a nervous system. So, but what if I send out a text to all of you and Dan responds, Mr. Thorson, I'm not going to be in school Monday. Him texting me directly, him to me, is that endocrine or nervous? That's endocrine. That I am the target to his text. Whereas if I were to go in the hallway and I said, Dan, come here. Everybody heard that. That's nervous. But if he texts me, Mr. Thorson, I'm not going to be in class, that's just him and I. All of you don't see that. That's just he and I. I'm the target. He's the sender. That's endocrine. So putting that on that, nervous system is sent everywhere. Endocrine hormone is sent to a specific target. Just like a text versus a tweet. Next.
Oh, also, by chance, I am actually not going to be here on Monday.
Psychic. You know the drill, right?
I just don't.
No, you know the drill as far as keep up. Okay. All right, targets. For the nervous system, can you tell me 3 parts of your body, 3 cells, 3 tissues, whatever, organs, whatever, that can actually receive neurotransmitters? What is the target of a neurotransmitter from your nervous system? Like body parts, cell, tissue, organ, something. What kind? Muscle. Okay, I'll take that. Muscle tissue. If I have my hand on a hot stove and my arm just automatically moves off of it, my nervous system told the muscles in my arm to move the arm. What else? I'm watching Avengers Endgame and all the Avengers assemble to fight Thanos and I have goosebumps. What hormone is causing me to have goosebumps? Adrenaline. Adrenaline is circulating through my body. How did my adrenals know to secrete adrenaline while I'm sitting in a theater watching a movie? Why did my adrenal glands secrete adrenaline? What? Okay, what part of the nervous system, or how did my nervous system know to tell my adrenals to secrete adrenaline? What am I doing in this movie theater? Watching. Is that one of my 5 senses? Where does the signals in my eyes go to? My brain. And my brain is all percolated from this movie. What is it going to cause my adrenals to do? Secrete adrenaline. And then I feel like, oh, I got the tinglies. Where we watch the crazy part of a movie, or you hear a very passionate part of a song, you secrete adrenaline so your glands can receive a signal. Your pituitary, your adrenals, your ovaries, your testes. None of you wanted to start puberty, but you did. What triggered your testes and ovaries to start producing estrogen and testosterone? What told those glands what to do? Well, technically your pituitary told them what to do, but what told your pituitary what to do? Your brain, your nervous. All right, finally, how does one part, what else besides muscles and glands can your nervous system communicate with? It's kind of a trick question. You got muscles, you got glands, one more. Neurons, other nerves. Very good. Okay. Now, for the target for hormones, what is the target of any given hormone? Some of you were kind of mumbling it a few minutes ago. Any cell that has a nothing? Let me write this out. Any cell with a blank for that hormone. What do you think goes in the blank? Receptor. My phone has a way to receive a text sent to me. Your phone has a way to receive a text sent to you. It has a receptor. We call it a specific phone number. Okay, let's go to response. How fast do you think the nerve, like give me a unit of time, hours, years, decades, whatever. How fast do you think the nervous system is? Milliseconds to seconds. Yep. I didn't even put my full weight on that rock before I knew to get off the rock. That's how fast it was. So this is rapid. We're talking milliseconds to seconds. How about the endocrine system? Is it faster or slower than your nervous? It's slower. I mean, comparatively speaking, it is fast, but slower than your nervous. How fast are we talking? Seconds to minutes. All right. Range of effects. If you're walking barefoot and you step on a rock, does your whole body freak out? No. Just lift up your foot, not your whole body. So the range of effect for a nerve signal is localized and specific. Tyler, you're a runner. Have you ever stubbed your toe? Okay. When you stub your toe and your toe is throbbing with pain, how's your elbow feel? How about your ears? Why do they feel fine? Because you didn't hurt those. The signal is only coming from your foot, so it's localized and specific. That's how the nervous system is. As far as endocrine, Jack, Dylan, you guys are relatively tall guys. When you started to get the growth hormone to make yourselves taller and bigger, did the growth hormone go to just like one specific spot, like Tyler's toe, or did it go everywhere? It went everywhere, made your whole body bigger. So that would be widespread. Hormones are widespread. Has anyone ever had an acquaintanceship with someone who was pregnant? Do their hormones just affect like their uterus, or is it widespread? Yeah, it's widespread. Kind of moody. Yeah, be nice, Tyler. Be understanding. And lastly, we have the duration of response. How long does the signal last? For those of you that have taken psychology, I'm going to look for a very key word. I bet you probably can't come up with it. A nerve signal is short term. It's like a lightning bolt. Pow! Very quick. And the signal stops once the stimulus is removed. So here's a very key question I'd like to see if any of you who are taking psychology can remember. I'm going to draw a couple neurons here. You don't need to draw these neurons if you don't want to, but I want to see if you can think of this word. So here we go. Here's the cell body. Here's some dendrites. Here's an axon. There's the axon terminal. Here's another cell body. Here's some dendrites. There's an axon. There's an axon terminal. What do you call this region where the axon of one neuron meets the dendrites of another? The synapse or the cleft. Yes. Okay. Which neuron is releasing the neurotransmitters? The one in the front or the one in the back? The first ones. This is the presynaptic neuron. This is all stuff that you had on your semester exam review last semester. And this is the postsynaptic. So here's my question. Neurotransmitters travel across the cleft, and then they go into the next neuron. What do you call it where neurotransmitters kind of, for lack of a better word, get sucked up back into the neuron that they came from? Bingo. Knew some people knew it. Reuptake. The neurotransmitter will get brought back in. I like to think of it like a firefighter. The firefighter receives the call. They go and put out the fire. They do their job. And then where does the firefighter go? Back to the firehouse. They go right back where they came from. That's what happens in neurotransmitters. The transmitters go into the cleft. They do what they got to do to pass the signal on, and then they get reuptake back into the neuron that they came from. And finally, for the duration of response for endocrine, this is longer term. We're talking minutes or days or even weeks. And it may continue after the stimulus is removed. You don't have to have the hormone there the whole time to actually produce a response. The hormone just kind of gets the response started. Jack and Dylan are pretty tall guys. They're not going to get shorter again if I remove growth hormone from their body. They're here to stay. Their size is here to stay. And that goes for all of them. You're not going to get shorter if somebody cut out your pituitary. Okay, well, that is the entire lesson. we will, let's see what we got next time. Next time on Monday, we're going to talk about homeostasis. Yes.